This is the last section of section 3.1. This is part C. We're going to be looking at the horizontal and vertical line test. But before that, we're going to introduce a special type of function that has unique outputs. This type of function will be called a one-to-one function. The definition of a one-to-one function is the following. A function is one-to-one if each input is assigned to a unique output. It turns out that one-to-one functions are pretty common. Let's look at an example of a one-to-one function. So given the domain on the left-hand side with the numbers 1, 2, and 3, and the range on the right-hand side with 8, 9, and 0, a one-to-one function is going to assign each number in the domain to a unique number in the range. So 1 would go to 8, 2, let's say, just goes to 0, and 3 goes to 9. Another example of a one-to-one function is given by the graph of y is equal to x squared for the x values that are greater than 0. So we know that this is already a function. Let's just go ahead and draw its graph. And the reason why, again, this is a function is because for each input value, which again is the x values, we have only one unique output value, some y value on the graph itself. What makes this a one-to-one function is that each of these y values are unique. Let's go ahead and show that a function is one-to-one using the definition. Example 6. First is the area of a circle a function of the radius and then once we've shown, if we can show that it is a function of the radius, then we'll show that it's one-to-one. The equation of the area of a circle is given by the following. The area is going to be equal to pi r squared. And looking at this equation, we can see that the area of a circle is dependent on the radius. So if we change the radius, the area is going to change. Let me go ahead and write some of that down. The area is dependent on the radius. And the reason why the area is a function is because clearly each radius that we put into this equation produces only one area. And the reason, maybe a more precise reason, is because the radius is a positive number, and a positive number squared is always positive. So we're done with part 1, but let me just go ahead and write down, that again, area of a circle is a function of the radius. So let's move to part 2. We want to check to see if this function is one-to-one. Let me go ahead and start a new page. Again, the equation we're working with is a is going to be equal to pi r squared. In this case, again, the radius is always a positive number. radius r is greater than 0, which again tells us is that given a radius, plugging that radius into our equation produces a unique area. To see this visually, we can go ahead and draw the graph, which is going to look very similar to the previous example. So the graph of our function, the input is going to be given by r, and the output is going to be given by a. And we see that the graph of our function is going to look very quadratic. And because this is a function already, we know that each x value is associated to only one y value. But we can also clearly see from this graph that each y value is growing as our x values are growing. And so then each y value is unique. And we can conclude that the function a is a one-to-one function. So determining if a relation is a function is difficult. And in this example, what we saw was determining if a given function is one-to-one is also pretty difficult. And what we're going to do now is just introduce some tools that are going to help us solve these problems. So the first tool that we're going to look at is going to be called the vertical line test, and this is going to check to see if a relation is a function or not. So let me go ahead and summarize what the vertical line test says, and then we'll go ahead and write it down. What the vertical line test states is that if there exists a vertical line that intersects the graph of a relation more than once, then the graph does not represent a function. So let's test this tool out on a few different graphs. And we want to do the following. Do the following graphs represent a function? So let's go ahead and apply the vertical line test to both of these graphs. So we're going to go ahead and just draw vertical lines throughout random points on this graph. And what we see in this first graph is that this passes the vertical line test because for each vertical line that we just drew, each of these vertical lines only passes through once. Now applying the vertical line test to the other graph, let me use a different color this time. what we see clearly is that this graph fails the vertical line test. And again, the reason why is because we can find multiple different vertical lines that pass through this graph twice. So what we can conclude is the graph on the left-hand side is in fact a function, and the graph on the right-hand side is not a function. Now that we have a tool that can check if a relation is a function, let's go ahead and add another tool that's going to allow us to check to see if a function is one-to-one. So this next tool is the vertical line test. The horizontal line test. And again, this is going to check to see if a function is one-to-one. So the horizontal line test states the following, that if there exists a horizontal line that intersects the graph of a function in more than one place, then the function is not one-to-one. Let's go ahead and use this tool to determine if a few graphs of functions are one-to-one. So this is going to be the final example, example number 9. Are the following functions one-to-one? So on the left-hand side, again, we have this polynomial type function. Maybe it looks something like this. And on the right-hand side, we have this function that almost looks like the square root, or in this case, half of x squared. Apply the horizontal line test to the first example. So far, it hasn't failed. But already at this point, we see that we have a horizontal line that passes through 3 different points. And if we continued on, we could find more such horizontal lines. So this fails the horizontal line test. And we can go ahead and apply the horizontal line test to the function on the right-hand side. But what we notice is we can't find a horizontal line, that passes through this function more than once. And so this is going to pass the horizontal line test. And so what this tells us is that the function on the left-hand side is not one-to-one. And the function on the right-hand side is in fact one-to-one.